Hi, everyone. Welcome to our talk. My name is Ciprian Hacman. I'm a senior software engineer at Microsoft, working on Kubernetes, not AKS. And I'm dealing with scalability, platform engineering, and other interesting stuff. And in my spare time, I'm contributing to kOps in particular, but generally to many projects in the Kubernetes ecosystem, especially cluster lifecycle related. Thank you.
And I'm Justin Santa Barbara. I am a software engineer at Google. I've been at Google for about 7 years and working on Kubernetes and kOps for longer than that. So don't want to admit that, but it's true. But we are two of the maintainers of kOps. But this is not a this is a maintainer track talk. It's not specifically about kOps. We're really talking about more of the Kubernetes cluster lifecycle ideas, particularly a new idea that we see evolving, and we want to sort of highlight that idea and get your feedback and your input. I see many of the people working on it in this room, so thank you for making the trek all the way down here to the bowels of wherever we are. And we do welcome your input, particularly afterwards. We'll try to save some time for sort of Q&A and heckling. So yeah, we're going to talk to you about this move happening, which we see, which is basically where we're moving from installers that manage both the control plane and the nodes to a world where we think of those two as very separate responsibilities that might even have separate tooling that is sort of best of breed for each. Our goal is to give you the context to help you to understand whether that's a good idea or not, or make up your own mind and get the lay of the land in terms of what the various projects out there are doing and where you might want to contribute. So historically, or even to this day, a Kubernetes cluster typically comprises both a control plane and worker nodes. And reflecting that, the installation tools, the installers that we have today, will create and manage both that control plane and the nodes together. It's easy to understand, it's effective, it looks great in docs. You just have that one line kOps create cluster or G-Cloud container or whatever it is, that one line that gives you a working Kubernetes cluster, and it's a magical experience. However, it does introduce day two friction that maybe isn't as necessary as if we treated those two concepts separately. So things like upgrades and scalability and cloud portability of your node descriptions become harder. One of the things that I think we're seeing is there's increasing demands on the nodes, particularly with the rise of accelerators and GPUs. I have to say AI, so because of AI. So if we had an API for node programming, we could maybe do more magic there. And the community is tackling a lot of these issues, generally by moving that node management out of installer tools to the excellent Kubernetes control plane. And so we want to highlight those things from around the ecosystem, and I will emphasize we're highlighting those things more than we are proposing, our new project that you should all move to. That's not what we're here for. This is about what's happening and how we see the world.
Okay, control plane is the brains of the cluster. They are hard. Hard to build, hard to maintain, hard to scale. They contain etcd or similar database, possibly managed separately from the cluster. There's kube API server, kube controller manager, kube scheduler, but there's also kube DNS, which is, you cannot do it without it. Cloud controller manager, which is needed pretty much for any cloud. And maybe you can say some cloud-specific workload identity service, optional but highly recommended. And obviously, autoscaling. There's literally no cluster without autoscaling there. Okay, nodes are a totally different story. Instead of the biggest focus being on high availability of a small number of machines, we're focusing on lots of different machine types, more dynamic, unpredictable resource demands, greater number of machines, and much more money in general. So you're not gonna care if one node dies, you just want one as soon as possible to replace it, right? With the control plane, it's not that, that easy. All right. kOps is an open source production cluster management tool that is part of the Kubernetes project. We've been working on CRDs for years. I'm ashamed to say that, but the primary consumption mechanism is the kOps CLI. There are CRD-like objects for cluster instance group, but we keep this traditionally in object storage, S3, GCS, Azure Blob. And also traditionally we integrate with cluster autoscaler for scaling. But to configure a new flavor of node or a new concern, you have to go through the CLI. You cannot do it as a cluster user. So we put the node creation or the topology firmly in the cluster administrator's hands, not the cluster user. So definitely not the Kubernetes API. Cluster autoscaler is very reliable, has been around, let's say, since the beginnings, but it has its own limitation. It uses higher level primitives for the cloud, mostly, well, it's based on node groups. So it uses autoscaling groups, MIGs, VMSS, or something similar behind it. And you just set up a template and you say, hey, I would like n nodes of this type. Please do whatever you need to do it. It's kind of indirect, you know, like pushing and pulling something. You cannot do proactive scale up with it. It only reacts based on your needs. You cannot do easily per node control, so you have no idea what kind of node will pop up where, like in which availability zone. In the end, it's the node group's role to do that. And it's kind of unpredictable. As I was saying earlier, if you are targeting with your node group multiple availability zones, you will be surprised where it comes up. And if you want to do, how do you say, balancing of pods across availability zones and things like that, you kind of have to find different ways, like multiple node groups, each one in its own availability zone, and so on.
So, I mean, I think the message is, you know, there are these technologies which are tried and tested workhorses, and they've got us here, and they have stood the test of time, and they work well, but they do predate, like, CRDs. And they don't offer Kubernetes APIs natively. They weren't really designed around those sorts of ideas. And traditionally, like the management of nodes has been done with this cluster autoscaler tool. The management of clusters has been done with tools like kOps that are built around pre-CRD thinking. And we think that there's a great opportunity to actually embrace the Kubernetes APIs here, and we see some excellent projects that have started to do that. I love little pictures, by the way. I've never seen it produce such a good outcome, so I am quite proud of those. Little Kube API superhero guy. This is not the Karpenter logo, but again, the AI produced an excellent result, so I was like, that's so cute, we gotta take that one. So Karpenter is an in-cluster API, so it embraces CRDs. It is based around CRDs from the inception, and it creates CRDs that are designed to create nodes or groups of nodes. And the thing that this enables is it means that applications or operators could create those nodes. They can create pools of nodes. To be fair, we haven't actually seen like applications do this yet, but I do think that this is the thing which we're all watching for, that moment when the VLLM operator spins up its own instances that have GPUs. It is a newer project. It doesn't, it's not perfect. It doesn't yet cover all clouds. GKE has a rival called Compute Class, but there are encouraging signs. There was a recent architectural split between the core and the cloud provider logic. It was recently brought under SIG autoscaling. It's very much now part of the Kubernetes project. So I think it's a very promising project, and that gets a lot of things right. Another one that gets a lot of things right is Cluster API. Cluster API is a set of CRDs, real Kubernetes APIs, for creating control planes and nodes. It is more integrated, like more of the monolithic approach, more like kOps. Karpenter is has a better divide there between the two responsibilities. Another shortcoming or problem with Cluster API from this perspective is that it traditionally runs in a management cluster. And so node management is Kubernetes, but it is not available to applications. So this hypothesized use case where suddenly applications are able to create nodes dynamically for exactly what they want, it becomes harder. It would be great to have a user space API for machine deployment or machine in Cappy. And I see Elmiko here, who is working on Karpenter on Cappy, which is a little confusing, but could be an excellent API to deliver that and give us that reach of Karpenter, or give us Karpenter and extend the reach to all the Cappy providers. So that's another great project to watch.
Okay, what kOps is trying to do is to move the focus of kOps on the control plane.
I think your mic is off.
Oh, sorry. Sorry. So for kOps, what we're trying to achieve is to move the focus of the project on the control plane itself. So trying to build a better control plane, a more available control plane, and enable Karpenter and Cluster API in the future to take care of the nodes. So, sure, with a layer from kOps, but mostly use these tools to drive the user needs. Users should be able to dynamically create nodes and groups of nodes as they please from inside the cluster using the agreed ecosystem. Existing kOps user cases will still be supported, so we're not going away from traditional instance groups.
Yes, so yeah, that's our sort of broad plans for the direction in kOps. We can't speak for obviously other projects, but we think this is a huge unlock for the community. I did say that we haven't seen those use cases arise yet. This is where we've saved hopefully enough time to have a good discussion about this and whether what those use cases are and how we should pursue it. But we do think that we get a lot of functionality here. So not having to deal with a Kubernetes API and a non-Kubernetes API will mean that your complexity is much lower. It should be much simpler. You can have a more homogeneous stack when you're managing your applications and your nodes, at least. You don't have to learn two different tools there. You don't have to have two different workflows. We think that this is an incredibly expressive API that we've sort of reached at from two different directions, both Cluster API and Karpenter. We are very excited about the idea of, for example, proactive scaling or proactive creation of nodes, or running on whatever GPUs I can get. Like just spin up GPU nodes and I will make it work. I will split it up based on whatever I happen to get. That is a huge problem. Availability is a huge problem right now. And that's something which I think this really can solve today. I think going forwards, we can think about some of the assumptions, like follow the sun. Follow the sun has historically been about the idea that the demands on computation change in the diurnal cycle. But maybe in a sort of energy-constrained world in future, we might actually say the follow the sun is where the energy curve is. So if there's more energy and cheaper computation over there, I want to go do that. And I know about that because I'm linked to an API that's giving me the weather forecasting, and I have a complicated controller doing this. That would be, we could build that in cluster autoscaler, or you could ask your cloud provider to build that for you. But the Kubernetes community, I think, can do a great job of creating a better one, perhaps, or more quickly. And I think that it is pressing. And I think that's really the goal here. Like, can we, by creating this API, or spreading news of this API, how do we unblock you? What use cases do you see? And how do you want to use this new functionality? And so I think we've saved actually a lot of time. We've done well. We've saved a lot of time for questions. So thank you. And when I say questions, input as well. It doesn't have to be a formal question. Heckling, disagree, agreements, anything like that. There are some mics, but if we need to, we can do roaming. But thank you.
Can you hear me?
Go.
Yes. So in this model, how will you create a Kubernetes cluster?
Right, exactly. So this is the idea that there is a separation of the concerns, right? So there will be one tool that creates the control plane and one tool that creates the nodes, and the nodes can be created by creating, for example, a machine deployment in the CAPI language, or a node pool, is that right? Node pool in the Carpenter language, as CRDs, as instances of CRDs that you would literally kubectl apply to that control plane that comes up. So when you start a kOps cluster in this new world, you might not get any nodes. I think when you create a GKE autopilot cluster today, you don't get any nodes. That's basically up to you. GKE autopilot uses basically uses something like cluster autoscaler, so it will see those pods. But with this API, we could instead say, well, I will now configure the nodes I want, or the strategy for the nodes I want.
Okay, so basically I can just first create the control plane that's not attached to any nodes, right?
Sorry, I missed that last bit. Yes, you would just create the control plane and...
That's not attached to any nodes initially.
Exactly right. No nodes initially.
I see. And that control plane, would it run on a host or management cluster?
So the question was, does it run on a management cluster? I think it's a separate concern. It's up to you type thing. Like, I think we want to see, presumably CAPI would run it on a management cluster in some configurations. I think kOps would probably run it on some VMs. Other tooling can do other things, and I think that that's sort of part of the beauty of this, right, is we know what's, like Ciprian listed the sort of components that are running in that control plane, and it's something that you can think of as like, it's a fairly well understood workload that you can run in different configurations based on, you know, what you think you're targeting.
Okay, thanks for explaining. One more question. So once I have that control plane, right, then what is going to be creating those nodes and then having them attached to it?
Sorry, did you hear? I missed that last bit. I'm sorry. What is going to be created?
Once the control plane is up and running, right? What's going to be responsible for creating the worker nodes and having them join to that control plane?
So I think the question is, once we create the control plane, what is responsible for creating the worker nodes and having them join? Yes. I think what we will probably do in something like, so first of all, it can be a decision of like the installer tool of how much it gives you automatically. What we'll probably do in kOps, I'll just give it as an example, is we will have a policy where we will automatically create nodes that sort of fit your workloads on a sort of similar to cluster autoscaler. But then we also will enable you to explicitly create nodes if you want to create, you know, a set of GPU-enabled nodes that have a certain shape or whatever it might be.
Okay, I see. But when I do create those nodes, I'm guessing this will be, I'll create some custom resource in some cluster, right?
It will be yes, it will be a CRD in your, the cluster. I think that's the big unlock is if that CRD is in the same cluster as your applications, because we think then your applications can start to program that API. And if you want to, you don't have to have two GitOps repos. You can have one GitOps repo that includes your applications and the nodes that back those applications.
Okay, thank you.
Thank you.
I just want to clarify my understanding. So are the control plane and worker nodes still going to be in the same cluster? Or are we talking about that kOps will create like a management cluster and then the worker nodes on a separate clusters?
So the question is, like, how do we basically, is it still the same cluster between the control plane and the worker nodes? I think one of the problems here is we have defined a cluster as both a logical and a physical thing. So a Kubernetes cluster, for most people, unless you're doing an unusual use case where you aren't running any workloads, is going to comprise a control plane and some nodes. And those, almost by definition, are together, that comprises a Kubernetes cluster. Now, where you put those physically is basically entirely up to you, right? Like, it is totally reasonable, it is totally acceptable to put them all on virtual machines running on the same laptop, for example, right? It is totally possible to put them all onto one physical machine, right, and not have a separation there. Obviously, there are different shortcomings of all of these things, but I think from a logical perspective, the cluster is the control plane and the machine and the nodes, and we want to see those as separate concerns.
Okay, thanks.
Yeah.
So at some level, when you request more nodes, using Karpenter, something has to actually actuate it. That means it holds cloud credentials, is going to consume quota, has to make decisions at that level. Do you see space for having those credentials, that level of permission, in a management cluster or off cluster in some way, and only actuated by the thing that is accessible to workloads? And if so, how are you going to choose what is managed in location A versus what is managed in location B? Do you see them as different roles inside of a company, same person doing both? Could you elaborate?
Do you want to, or I mean, I think I think you snuck in a different question at the end there. The different roles, I think, like, we still want, I imagine most people for most applications, most companies for most applications will continue to have their application teams not manage their nodes, right? It is a specialized application team that needs to manage their own nodes. That, I think, was the easier of the two questions. The first question is the security question, right? Like, I think this is one where, again, we can explore many options as a community. I think one of the clever things that the clever people that built the kube API server, see, I'm pandering, did is that there's no distinction between something running inside the cluster watching CRDs versus something running outside the cluster watching CRDs. So it's almost up to you, right? Like, you could have the same CRD, maybe even with the same controller, and choose to run that controller on the control plane, choose to run that controller in somewhere else outside the cluster, or you could choose to run in a management cluster. For kOps has tried to do self-contained clusters, so we will put it on the control plane nodes because we don't really have anywhere else to put it. But if you have somewhere else to put it that is perhaps more secure, that is a great thing to do.
Okay. I look forward to seeing the policies
Yes.
that develop on both sides.
Thanks, Ciprian and Justin. This is a really cool talk. I'm very excited by what you guys are talking about, and I think it's neat. So a couple questions. First, Cluster API and Karpenter are both complicated and, just sometimes difficult to work with for their own reasons. What are your thoughts about adding another kind of debug surface into whatever structure we're building with kOps and whatnot?
Adding another, sorry, which structure?
Another debug surface. Like, if Cluster API is going to be in the mix now, then if something goes wrong, I'm going to have some knowledge of how to understand the Cluster API controllers or something like that.
I have my own opinion. I don't know if you have your own opinion. I think that this is not necessarily specific to Cluster API or Karpenter. I think it's inherent to any complicated set of Kubernetes controllers interacting through lots of types. I think if we have, I'm being very careful, if we have maybe some conventions around status conditions and some tooling that can consume that and expose it in a intelligible way, might be AI, might not be AI, but I think that tooling is, I think, why we have struggled to, the lack of that tooling is I think why we've just struggled to come up with clear guidelines on what should be in status conditions. And I think that would be that's where I would personally invest first before inventing new things. But of course, we're going to build new things to enable that, right?
Sure. So I mean, at some level, it sounds like what I'm hearing is like, the natural evolution of these things is there's some acceptable level of complexity that comes into this. And hopefully, if we find gaps in the user experience and the triage ability of something like Karpenter or Cluster API, we'll improve those tools. We'll make it better and easier for operators to understand these things. Is that?
I think so. And I think that there are cross-cutting things we can do. Like different kubectl surfaces, for example, or different kubectl commands that could go and like not be one-to-one with the underlying APIs and introspect like the tree of owner refs and like get information out of conditions and surface it in a sensible way. We have good root, and maybe even go and look at the logs. We have good root cause information, and it's all in there in the API, and everything is like one of the amazing things about Kubernetes, everything is published to that kube API server. We just are quite rigorous in having kubectl commands be one-to-one with API calls broadly.
But I think you're absolutely right on that, because with, let's say, cluster autoscaler, which would be the traditional alternative, right? You have zero control over what you get from the cloud provider. If the cloud provider wants to expose why it failed or why you got something, you might get it somehow, but generally you get or don't get anything from it. You get a failure with some strange code, and you have to go debug or call your support engineer and say, hey, what's happening here? At least in this scenario, you have more control over what happens in the cluster. You can see a log, you can see a status in your CRs. I mean, should be easier from some points of view also.
Cool. So one other quick one here, because I noticed the line's getting long again. You mentioned predictive autoscaling and the cluster autoscaler and whatnot, and I'm just curious, have you looked at the provisioning request and the upcoming capacity buffer APIs?
I mean, yes, we're working on those also, right? Okay. Like, I don't want to say that cluster autoscaler is doomed because it can never implement this. Right, yeah. It's that it wasn't baked in from the start. And like, we're saying this as maintainers of a tool that also was built in that era, right? Yeah. Like, we can obviously retrofit it. But I think that there is a lot to be said for starting with that Kubernetes API surface and the idea of putting it into user space so that it is more programmable.
Yeah, absolutely. Thank you.
I think we might have to cut this off, but yes, go for it. And then if we need to, we'll carry on outside in this hallway.
I have two questions. The first one would be, you mentioned that this can't be done using kubectl CLI, and it's done using kOps CLI. What was the motivation behind doing that?
Sorry, did you hear that?
Can you repeat the question?
Yeah. I think in one of the slides you mentioned that this is done using kOps CLI instead of kubectl CLI. What was the motivation behind that? Yeah,
it's as I understand the question, it's like, why is everyone, we have these CRDs in theory, why is everyone not using those wonderful CRDs? I think that's on me. Like, the experience of using the CRDs is not as good for, using the kOps CRDs is not as good as the kOps CLI today. It's only half-baked type thing. So it is more that they are not yet able to get the same functionality by using the functionality we have today in kOps CRDs. So the majority of users that want to use kOps get that functionality through the CLI, which then means that they are not using the Kubernetes CRDs and the Kubernetes control plane, which means that they aren't able to use the same GitOps tools and all of those values. It's just that we haven't built that functionality out to the point where it's useful yet.
Okay. And will this have any impact on the node upgrades if you move the node management to the control plane?
Have impact on, sorry?
On upgrades, you mean?
Will this have any upgrades? Will this have any effect on the node upgrades? Because if you move the nodes to the control plane, how will that look like?
Yeah, I think it will have a huge impact on node upgrades for the better. I think that the ability to schedule node upgrades in a way that is much more application aware, maybe more continuous node upgrades. I think those are great things that we can now build very easily using Kubernetes controllers, and they were very hard to do previously. So I think it will. And I think with that, I'm surprised no one's kicked us off stage yet, but I think we are over time. So if there are more questions, we will hang around outside, and let's continue there, if that's okay. Thank you.